Hello and welcome to CII's research webinar, Facility Standardization for Program Success. We appreciate you taking the time to join us. This webinar presents a research topic originally planned for our annual conference. I'm Mike Pappas, CII's Associate Director for Deployment. If you go to your GoToWebinar control panel, you'll see a gray bar labeled Questions. Feel free to enter your questions there and we'll address them after the presentation. With us today, we have Research Team Chair Tim Oakleaf from ONEOK, academic researchers Jinook Choi from UNLV, Young Hook Kwok from George Washington University, and Jennifer Shane from Iowa State University, and team members Kathy Farina from DICAT Solutions, Michael Cluck from KBR, and Annabelle Pico from the Williams Companies. Ladies and gentlemen, thank you for joining us.
Research Team UMM-01's presentation on facility standardization for program success. Last year at the CII Annual Conference in San Diego, we showed that the application of a standardization strategy when companies intend to replicate construction at several sites can substantially help a project team's ability to achieve the company's targeted project value objectives. Our case study from 8 standardization programs, which had 45 projects in total, showed that it is possible to achieve significant cost and schedule savings. Most companies miss the opportunity to capture standardization benefits due to schedule pressures and lack of pre-investment in design, fabrication, procurement, and modular standardization strategies that can be reutilized several times. Companies that have taken advantage of standardization have learned how to use the first project in a program of similar projects to establish and capture value. This research builds off the completed UMM-01 standardization report presented last year. From our case study, we showed that with facility standardization, it is possible to save 10% total installed cost, 15% on schedule, and 25% life cycle costs, which includes commissioning and startup and operations and maintenance. Last year, we showed that a company can save significant costs through implementation of standardization across the various functions in a project that provides learning curve benefits in subsequent projects. This graph shows percent spend savings per function compared to customized projects represented by the 100% dashed line on the y-axis. Companies with standardization programs also highlighted that as each additional project was completed, additional savings was achieved by functions summed across the project. Similar to the cost chart, the programs also had savings in schedule across the functions, providing significant overall savings. And again, program projects gained additional duration savings as each project was completed. Facility standardization does not have to be applied to 100% of the project scope. Last year, we demonstrated how component standardization works from our case project examples. Compressor and pump stations, well pad sites, as well as fractionation and gas plants benefited from strategic standardized modules and standardized equipment packages. Here is an example of a true well pad that shows system level standardization approach. So let's recap what is standardization. Standardization is the development and use of consistent design to align project stakeholders, objectives, and scope to capture and optimize schedule, cost, and value. Our team completed a SWOT analysis that summarizes strengths, weaknesses, opportunities, and threats of facility standardization. Strengths include achieving significant cost savings, increase in efficiency and consistency on projects, designing once and reusing multiple times, and improved agility and increased predictability. Weaknesses that teams have to manage are the cost and time for the first project, resistance to organizational change, and optimization versus customization. Opportunities that program projects can enjoy are more predictable resource management and the ability to leverage suppliers and contractors across multiple projects. Threats that project teams have to manage and monitor are the environmental and regulatory criteria, market conditions, and the ever-evolving technology. So the same as last year, the essential question for our research was, how can higher levels of facility standardization be achieved in the upstream, midstream mining sector? Our phase 3 research hypothesis and objectives all supported this essential question. In San Diego, our research team presented a pyramid of solution pieces to help companies increase standardization and achieve predictable, fast, agile, cost-effective projects. The pyramid is comprised of 4 levels. Economics of standardization provides an understanding of the fundamental benefits and trade-offs with facility standardization. Standardization decision-making model, a user-friendly tool that provides an early, high-level, systematic review of key issues in standardization. Its objective is to help practitioners determine the feasibility of standardization by identifying the benefits, business drivers, impediments, and risks. Critical success factors and enablers identified 15 critical success factors and enablers along with the responsible parties and the optimal timing of implementation. And last, innovative technologies and approaches revealed innovative future stretch technologies and management practices. The level of facility standardization in the UMM sector still falls short of the desired criteria. So what is the problem and need? The capital projects industry needs additional guidance on how to analyze and justify standardization and how to exploit the benefits more effectively. When the industry better understands how to implement facility design standardization and have buy-in on the economic benefits, the industry will be able to achieve higher levels of facility design standardization. We were very fortunate to have a highly experienced and energized team with over 298 years of combined experience, most of whom have worked multiple standardized projects. Our research process was very extensive, and we invested nearly 65 hours in face-to-face and virtual meetings, equating to about 700 work hours. Aligned with the original essential question and problem and need, we added 2 solution pieces to help companies achieve standardization: business case analysis and work process to the pyramid of solution pieces. And we revisited one existing solution piece, critical success factors, to increase standardization. By adding 2 more solution pieces, this research work product will contribute to the company's overall ability to meet business objectives, creating increased predictability, agility, and cost effectiveness. Also, CSF validation will provide a better understanding of standardization CSFs and their current accomplishment status and insights for the industry to achieve higher project performance by accomplishing the standardization CSFs in the right phase of the project. And now I'd like to turn it over to Kathy to kick us off with the first additional solution piece, business case analysis. Kathy?
Thank you, Tim. The first additional solution piece the RT developed is the Standardization Business Case Analysis Model. This is a tool that analyzes and justifies standardization. It can be used to summarize the value proposition the facility standardization has to offer in the form of cost and schedule savings. Last year, from the 8 standardization program case studies surveyed, we asked an independent question: what was the actual life cycle cost and schedule savings compared to the conventional method to their standardized projects? Overall, 8 standardization programs, which had 45 projects, saved an average of 25% of life cycle costs and 15% of schedule. This provides market value for both the TIC cost of a project and time to market, which also offers both cost and schedule predictability. Last year, our team explained how facility standardization can help the project save costs and schedule. In addition, there were 13 benefits and 6 trade-offs identified from the research, and these are the backbone of conducting the business case analysis for facility standardization. The primary objective of the business case analysis model is to provide a tool that practitioners can use to analyze and justify if facility standardization is the right approach for their program. The tool will calculate a program's cost and schedule savings utilizing the facility standardization approach. It provides a definite answer with cost and schedule data. It is designed in Excel to be user-friendly and be iterative and flexible. The tool can also be used in conjunction with the standardization decision-making model. The tool is organized into 2 options. The general savings option is a higher level tool that estimates the cost and schedule savings utilizing percentages. This option will typically be used when information of the program is limited. Then there's a detailed savings option. It is a tool that utilizes the 13 benefits and 6 trade-offs and allocates costs to those to generate savings. This option will typically be used when information of the program is more available. The tool begins with an introduction page, which gives the user the tool's background information, instructions on how to use the tool, and the relevant CII publication that should be read in conjunction with this tool. There is a Program Information tab that asks the users to insert the basic information on the standardization program, the standardized projects, and the level of standardization. This includes the program name, but most importantly, the number of projects in the program. The user should note that in order for standardization to be feasible, there needs to be more than 2 repeatable projects in the program. The user will also input the level of standardization that program would target. The level of standardization varies and can be at an equipment level, package level, system level, or project level, as defined by the process industry practices. The next section will ask the user to enter the estimated installed cost of the standardized systems, equipment, or components, and the non-standardized components for one project. The tool will then automatically calculate the total installed cost based on this information. This will help the user calculate the percent standardization based on the installed cost of the standardized systems, equipment, or components divided by the total installed cost of the project. Understanding the percent standardization will assist users when assigning percentages for the cost and schedule savings in the General Savings tab. Typically, assuming that all of the critical success factors will be successfully implemented, the users can expect a higher percent of standardization can lead to a higher percent of savings. Now we're looking at the General Savings input page. It is a high-level analysis to estimate the cost and schedule savings based on the user's expected savings per each function. The functions included in the tool are engineering, procurement, fabrication, construction, and commissioning and startup. The user will input the cost and schedule per function of a custom one-off project on the left-hand side. Then to the right of the tool, the user will input the percent cost or schedule per project when compared to a custom project. Project 1, there will typically be no savings or potentially a higher cost seen due to the standard design being developed. As you can see in this example, the first project percentage for the engineering is inputted at 110%, and this is due to the additional cost to develop the standardized design. The remaining project percentages are input lower due to the estimating savings. The tool will offer guidelines to estimate the percentages of cost and schedule per project based on the benchmarking data from the research performed last year and the detailed cost and schedule factors. This is an example of the benchmarking data that will be available. The benchmark data is based on the data that was generated from our 8 case programs by function and number of standardized projects for a reference. The percent standardization can be used as a guideline to help the user choose the appropriate percent cost for each project as discussed in the previous slide. However, the RT would like to note that this data is provided for reference only. The users may be cautious utilizing this data as the case projects may be skewed. In particular, percent savings can vary depending on the generation of design, the types of projects, and experience with facility standardization. Another tool that will be able to assist the user is a detailed list of the cost and schedule benefits and trade-offs based on the research performed by the RT last year. The users can navigate to the cost and schedule factor page from both the general savings and the detailed savings input tabs. This will allow the users to better understand the cost advantages, the cost disadvantages, and schedule factors to help assist with deciding on the percent savings on the general savings tab or the cost savings on the detailed savings tab. After all the information is entered into the general savings input page and the user continues, there will be a general savings output page that summarizes the cost and schedule savings for the program. There will be an overall program savings section and a detailed program savings section per project section. On this slide, we are looking at the overall program savings that break down the savings per function and has total program savings, including all functions at the bottom of the cost and schedule tables. The other section of the summary table summarizes the overall program's cost and schedule by project and function. As you can see, the project cost and schedule decrease as the projects in the program increase. At the bottom of the summary table, there is a graph to illustrate the program cost and schedule by function and project. And as you can see, the project cost decrease, illustrating a savings for the overall program. The detailed savings input page is a template that will allow the user to be able to input estimated or actual savings and the estimated or actual cost per the required number of projects. The user can use the expand button on the left side of the page to evaluate the detailed factors that are embedded in each function. The estimated or actual savings is the summation of the detailed factors, or the user may add the saving values directly into the overall function box without considering the detailed factors. In addition to inputting the savings, the user can input the cost per project and function. The user has the option to print this page or go to the detailed savings output page. This is an expanded view of the detailed factors per function. As you can see in the upper circle, the factors are part of the benefits and trade-offs, and these are pre-populated in the template. There is also an option to select other factors such as safety and quality factors, as indicated by the middle circle. And in the bottom circle, there is a box that allows the user to input a custom factor that may not be part of the detailed factors. The detailed savings output page will summarize the cost savings and trade-offs and show the detailed savings results. This slide illustrates the overall cost savings for the program and per project by function based on the detailed savings input page. Lower on the detailed savings output page, it'll provide a graph that illustrates the total cost savings per project. In this example, the estimated cost savings are increasing as the number of projects increase. It can also be observed that the tool only allows for 5 projects at most. While it is understandable that some standardization programs may have more than 5 projects, once a user can envision general and detailed savings for 5 projects in the program, the savings curve flattens and will maintain similar savings from project 6 and on. I would now like to welcome Michael to discuss the second additional solution piece, the standardization work process.
Thank you, Kathy. Tim introduced you to the benefits obtainable by standardization and reviewed the 4 solution pieces needed to obtain best standardization potential. He also identified the 3 new solution pieces for transforming the theoretical research into practical tools. Kathy addressed the first new solution piece, the business case analysis. I will be addressing the second solution piece, the work process. So what is this actual work process for standardization? To help visualize the scope, we grouped the standardization key tasks across the typical project phase splits from opportunity framing to operations and maintenance. Focus your attention on the first two phases, opportunity framing and assessment lumped together, and selection, sometimes known as pre-feed. For the first project in the standardization program, completion of the tasks identified here is the key to the success of the program. Think about it. In opportunity framing, you need to determine your market, validate business drivers, develop a plan and work process, and most importantly, obtain management approval. In the selection phase, the newly approved program must be further defined and detailed with additional scoping and scheduling, examination of supply chain options, O&M, and other considerations, with the end result being the validation of the economics and development of the basic engineering design. At this point, the standardization program is identified and set. Tasks for basic design, FEED, and execution, EPC, are to develop the plans that will keep you on track and following the guidelines set, and to help you not lose sight of the standardization goals. Key to this success is the assembly of a quality team with both singleness of purpose and the authority to maintain the task goals previously set up in opportunity framing and assessment and selection phases. As Project 1 nears completion and the commissioning and startup and O&M phases, special emphasis must be made on capturing potential optimizations and lessons learned. These will be potentially beneficial for both 2+ projects as well as any first major update of the program. If you did your homework on project number 1, all subsequent projects skip immediately to basic design or FEED. In some cases, even the basic design is abbreviated. While it is expected that there may be some adjustments in this phase, a well thought out program will have taken these variations into consideration. For example, different foundation supports may be required for a standardized skid, but the skid itself does not change. Elimination of the first two project phases on these subsequent projects is where significant cost and schedule savings are realized. The facilities optimization chart is a different visual for the work method. Project 1, the top line, utilizes all project phases as described before. It'll be the longest and most expensive project you will see in the program due to the extra market, program research, and other unique activities of Project 1, indicatively shown by the length of the bars. All subsequent projects immediately kick off at basic design, and even this phase should be shorter than it was for Project 1. The rest of the phases within a project also decrease in duration, as symbolically noted by the bar length in this chart, as familiarity makes the project steps quicker. The result is a continuing project cost and schedule reduction, symbolically noted in the far right two columns by the declining dollar and time signs. At some time in the program, there may be a point where enough lessons are learned and optimization ideas captured that a program adjustment might make sense. Such an adjustment would require a quick opportunity framing and assessment and selection phase analysis to see if an adjustment of the program is worth the changes required. Summarizing the walkthrough on the previous slides, the top high-value tasks in opportunity framing and assessment are to obtain management buy-in for standardization and develop the standardization plan and work process. These go hand in hand and typically end up being working concurrently. Selection further defines the approach and develops the basic design engineering data. These are not the only important tasks. To simplify and summarize the research findings, the teams developed a Cliff's Notes to standardization, describing the key elements for Project 1 and for Projects 2+ for each of the phases in a project. The intent in this slide is to show the summary layout that was developed. The top includes a brief description of what happened in this phase. This is followed by the specific goals of the phase, the tasks to be addressed or listed, an abbreviated RACI diagram identifies who does what to whom, and finally, a list of deliverables to have been developed upon conclusion of this phase of the project. For each of the tasks identified in the project phase, a page was developed to further describe it. The example shown here is the market survey. The layout format is similar for all. The top is a brief description of the task. It is followed by who is responsible, the value of successfully completing it, as well as how difficult or easy it is to complete. A suggested methodology follows, along with keys to success and, conversely, things to watch out for, or pitfalls. On the right-hand side, there is a list of items to consider in the survey. Finally, on the bottom, there is a reference to the critical success factors. These will be explained later, but suffice it to say, meeting them is critical to the success of the program. The team developed an extensive RACI chart, but what I prefer to dwell on is the following slides. While the RACI diagram provides the same information, these two pie charts make a couple of points very clear. On the left, the owner is responsible for the success of the majority of standardization tasks, over 85%. This makes sense when you think about what a standardization program is. It is duplication, where program success hinges on how parochial you are in enforcing the critical success factors, for example, robust market search, no changes, continuity, and following the plan. On the right, as expected, the majority of the tasks, 50% for a successful standardization program, must be performed early. In this case, by the first two phases of the project, opportunity framing and assessment and selection. Remember, for subsequent projects, these two sessions disappear. These tables show the key accountable or responsible players for facility standardization. The orange boxes highlight those players. Program project leads or managers from the owner, and project engineering construction managers from the contractor. This slide shows a tool developed to provide a quick check on how well your standardization program is doing. Please watch this short 5-second video on how the tool can score your current efforts in terms of potential standardization success. CII's artificial intelligence emphasis on digital thinking has become very important in standardization. Along with standardizing and duplicating the engineering, design, procurement cycles already mentioned, there is also a need to quickly duplicate all the associated engineering, procurement, specification, and testing documents for each subsequent project. While some of these changes can be generalized by developing documents that address the entire program, there are always those documents that require specific project adjustments. Early identification of these documents that need project tweaking can be handled through the use of data-centric artificial intelligence methods. With proper forethought, the entire documentation side of standardized model can be designed to permit automated update of these necessary tweaks to provide specific tags, dates, references, etc. The following short animation of a recent standardized job runs through examples of what was identified and what the typical updates look like. Understand that even if one does not catch all of the specific project modifications, it is still worthwhile and will save hours over the traditional conventional document handling and approval. This short video shows an example of template-driven deliverables using data-centric algorithms. With proper setup, the quality can be 100% with delivery 90% faster than traditional document handling methods. This means faster and higher quality documentation to the equipment vendors, construction teams at site, and ultimately operations and maintenance. And now I'd like to introduce Annabelle, who will go into more detail on the critical success factors I previously touched on.
Thank you, Michael. Now I would like to talk about the third solution piece of the standardization critical success factors. Last year, our team identified 15 critical success factors, or CSF, and their associated enablers. We found that the industry needs better understanding of CSF, specifically in relation to their accomplishment status and relative significance, to ultimately drive better project performance. As a result, the primary purpose of this study was to provide recommendations for better project performance by identifying correlations between CSF and project performance through actual projects. In this slide, you can see the 15 critical success factors identified last year by the standardization experts. If you want to improve your agility, predictability, and cost effectiveness, these are the things to focus on during project execution. The team developed a sheet per CSF to show the optimal timing in the project life cycle, the lead party, and enablers. This is an example of CSF1, alignment and approval. Based on the data of 8 case programs, which include 42 projects, we have identified that projects that accomplish more CSFs tend to have better project performance. We will show you the data in the next 3 slides. The first graph that I'd like to show you is the correlation between CSF accomplishment degree score and the schedule performance score. There is a significant positive correlation between the two, which means that, in general, projects that accomplish more standardization CSFs tend to have better schedule performance. The second graph shows the same positive correlation between CSF accomplishment degree and cost performance. In general, projects that accomplish more CSFs tend to have better cost performance. And finally, we also notice the same correlation between the CSF accomplishment degree and the change management performance. In summary, this will improve your project predictability. We also wanted to know which CSFs are accomplished most commonly and which remain elusive or are difficult to achieve. The lowest CSF accomplished are CSF number 8, constructability of standardization, and CSF 15, feasibility analysis of standardization. The industry may put more effort into accomplishing these CSFs in order to achieve higher level of project performance. We also recognize that timing is also important in order to drive project success. We recommend that these 5 CSFs need to be implemented early. I'm talking about alignment and approval, standardization early identification, discipline to maintain standardization, constructability of standardization, and finally, feasibility analysis of standardization. Our team also investigated the combinatorial effect of CSFs on the cost and schedule performance. We used the information of actual cases to obtain a conceptual model of cost and schedule successes. Recipes for cost and schedule successes for facility standardization are accomplishing these CSF. CSF number 3, discipline to maintain standardization. CSF number 4, O&M consideration. CSF number 6, define the standardization approach. CSF number 7, the applied knowledge. Similarly to number 8, the constructability of standardization. And the last 3 are CSF number 10, benefits and trade-off, recognition of risk of standardization, and finally, supplier and vendor involvement. This slide shows a tool developed to provide quick check on how well your standardization program is doing. Please watch a short 5-second video on how this tool can score your current efforts in terms of potential standardization success. Now, to close this out, let me introduce Jennifer.
As we are wrapping up our presentation, I want to thank each of our presenters. Tim with his introduction to our efforts, Kathy with the business case analysis model, Michael with the work process, and Annabelle with more on the critical success factors. Each of these solution pieces contributes to our pyramid of solutions aiming to support industry in increased use of standardization, thereby increasing predictability, agility, and cost effectiveness. To enable your use of the pyramid of solution pieces, we are providing you with several user-friendly tools to help you achieve higher levels of facility standardization. The tools are the decision-making model, critical success factors and enablers, innovative technologies and approaches, the work process and guidebook, the work process checklist, the business case analysis model and tool, and finally, the CSF's accomplishment tracking tool. Now that you are all excited about standardization, in order to maximize standardization and therefore the benefits, there are several things that must happen that we can't do for you, but that you can do for yourself. First, industry leaders must act. Industry leaders, including yourselves, need to understand that there is a need to shift the current mindset that everything needs to be customized in order to optimize the outcome, but to understand that optimization in predictability, reliability, and cost effectiveness may come from standardization. To do this, industry needs to become aware of the need to change from a project mindset to a program mindset. While standardization can take place on a project, the most impact is felt across the program. In order to achieve the program mindset, there needs to be an alignment of leadership. This leadership is not just across the project and not just across one stakeholder. Industry needs to be cognizant of support for standardization at all levels of the project and program leadership by all stakeholders. To further this thought, we need to see a greater industry level collaboration. This collaboration needs to go beyond the typical stakeholders and needs to reach to suppliers and vendors. In addition to this change in industry, we as academics need to take these concepts into our classroom. Again, customized solutions are not always best. You as industry can support this concept by talking to student groups, classes, and your interns about standardization. Finally, to maximize standardization, we need to embrace digital thinking. As shown earlier in this presentation, new technologies, AI, and other advances in technology can be leveraged to support standardization efforts. And what can you do today? Check out our knowledge base for information on all of our solution pieces and tools, those that were presented last year as well as those presented here today. Please let this serve as your call to action to implement standardization. This slide concludes our presentation on facility standardization for program success. Any one of our speakers or research team members would welcome your questions and discussion on any of our solution pieces. Please feel free to reach out to any of our team members. Thank you.
All right. Thank you very much for that presentation. We have a few questions. The first one is, when will the presentation material be made available? And I can answer that one. It'll be available at www.construction-institute.org/blog tomorrow. When will the report and the tools be available? Tim, would you like to respond to that one?
Yes, Jen, could you go ahead and answer that question for the group?
Yes. Well, we have submitted our final report, tools, and the presentation materials to CII last week. As Mike mentioned, the presentation materials will be available tomorrow. Our report and the tools will be available by end of this year. Currently, CII is reviewing our product. Hopefully, we can have that report ready as soon as possible. While you wait for this year's reports and products, we recommend you to check our report and the presentation from last year. So it is currently available on our knowledge base website, and the new products will be also available on the same knowledge base website. So just simply Google it by typing 2 keywords like CII and facility standardization.
Thanks, Jen. Appreciate that. It seems the data from the case study projects were mainly from upstream, midstream, and mining projects. Are the findings applicable to just UMM applications or across industries?
Mike, I'll take that question. So the research is sponsored by UMM, Upstream, Midstream, Midstream with CII, but it's definitely applicable to all of our industries. So the tools that Jennifer mentioned in the wrap up will be beneficial to all member companies to support standardization.
Okay, another one. When would you use the general savings analysis compared to the detailed savings analysis?
Mike, I'm going to ask Kathy to answer that question for us.
Yeah, Tim, I can answer that. Thanks. So the general savings analysis really is intended to be used early in the program lifecycle. Really, it's used to justify the use of facility standardization on your program. So you can use it really as a justification tool on what the program savings are expected to be. As far as the detailed savings analysis, that one the intent is really to use it when you've completed a couple of projects in your program and you really have a better understanding of the savings, the actual savings. So that's the intent. You either can use it as an actual and kind of use it to allocate your actual savings per either the detailed factors or actually just as a function. You also can use the detailed savings analysis if you do have facility standardization experience and you have a good idea of what the estimated savings would be per project. So those are the kind of the 2 different intents for the tools. Hopefully I answered that, Tim. Back to you.
Thanks, Kathy. Appreciate that. Next question. How do you quantify the actual savings as a result of the facility standardization work process?
Mike, I'm going to ask Michael to answer that question for us.
Yes, the actual savings is best quantified by comparing the cost and time in the opportunity assessment and selection phases that are reduced to elimination in the second and subsequent standardized projects. This is best estimated really by the individual company in reviewing their historic perspectives on the duration and cost of these project phases. In addition, depending on the learning curve developed in this process, there are subsequent less dramatic time and cost savings with the optimization of subsequent phases of the project from basis design through the commissioning and startup. That helps.
Okay, thanks. Next question. From the SWOT analysis, what is the difference between optimization and customization?
Mike, that's a great question. I'll answer that one. So optimization applies to the standardization process where the purpose is to achieve the best design relative to a set of prioritized criteria and constraints. And the goal is to maximize factors such as productivity, reliability, longevity, efficiency, utilization, and execution at the lowest cost. Customization applies to modifying something to suit a particular need that may not have long-term value to your project objectives. which leads to rework and additional time to complete projects as those changes are recycled through the functions of a project.
Okay, thanks, Tim. Next question, when is a custom design the best solution?
Mike, I'm going to ask Kathy to help us with that question.
Okay, yes, Tim, I can answer this one. So when is a custom design the best solution? Well, when you're looking at a facility standardization program, you really need to look at how many repeatable projects you have within that program. And if you really only have, say, 2 or less repeatable projects, and depending on how large they are, it really would be probably more appropriate if that's all you have in your program, that's all you're ever going to use, to have a custom design then. But if you have anything more than 2+ projects in a program and they're repeatable, facility standardization really is what you'd want to use for that, for the program.
Okay, thanks, Kathy. Next question, how does standardization and modularization relate to each other?
That'd be a great question for Michael to help us with. Michael, could you take that one?
Sure, I'll be happy to. In the previous CII research effort that was RT 283 called Planning for Modularization, one of the 10 industry-wide enablers we identified was to begin the mindset shift at the university level in terms of getting students to look at modularization of a project as a base case scenario, and only when it wasn't a viable option to go back to the typical stick build option. This paradigm shift becomes even more important with a standardized program where multiple identical units are being planned for varying clients at different locations and possibly with different goals. Modularization provides the opportunity to build the project or a portion of it in a controlled environment with a stable, high-quality workforce, with further benefits from material and supply centers nearby. All of this provide the best opportunity to maximize the benefits of standardization. So really they go hand in hand, if that helps.
Thank you, Michael. I've got 2 questions about culture that I'm going to kind of combine here. How can you best initiate standardization culture in your company when employees' mindset has been wired to customize per project needs and scope? And the other one asks, how do you balance standardization with the common 3 bids and a buy approach that is still the way we tend to do business?
Mike, those are great questions. I'm going to take a stab at that. So thinking about the last 2 to 3 years working with this group and some of the war stories that project teams have told, managing projects and trying to achieve standardization, there's a few things that stand out to me. Number one is, defining the project value with the stakeholders early. You've got to anchor your project objectives and your capacities early in the project, and also that you have to set the design margin that allows components and systems to be standardized. And to do that, you've got to ask the tough questions to your commercial and management teams and get an answer. A lot of teams struggle with getting those parameters for success early in a project and find themselves chasing incremental capacities that waste a lot of time and motion. I think a couple other thoughts is you've got to use the first project in a program to capitalize on this standardization process that Michael walked through, and Annabelle highlighted the critical success factors, and then use the the cost tools to help tell the story related to value. I think another theme that I can highlight that a lot of our committee folks learned and championed in their personal companies is the pre-investment in front-end loading and feed of the project early, so that you can present those standardization strategies early to your stakeholders. And if you think about it, for most companies, the front end loading and the feed are 2 to 3% of the total installed cost of a project, and only take 3 to 9 months, depending on the size of the project. So if you can get that early funding from your stakeholders, so you can walk a project program through this process, then you are set up to present the standardization strategies to your stakeholders to go capture that value. And then I think the last thought is just, this research team put together a lot of valuable tools to help tell that story and define those opportunities. So, using those critical success factors at the right time in the process will help you support your recommendations. So that'd be some of my thoughts.
Okay, thanks for that, Tim. There are a lot of great solutions and tools. Where should someone start? Is there an order in which the tools should be used?
Michael, would you mind answering that question?
Sure, be happy to. I think initially you would want to look at the overall program that you're anticipating and determine, based on sort of the business case analysis that I went through, if it looks like there's a potential for significant savings. As soon as you see that, I would take the high-level approach of Kathy's cost analysis tool and look at that thing, and it'll, at least if you're not sure of the numbers, it'll give you an idea of what areas to look in and try to see where you can try to find some numbers that you may be missing for such a program. At that point, after you've seen the thing and it looks like it's a go, there's the remaining tools that offer just how well you are anticipating and meeting the critical success factors, and making sure that you're trying to hit some of those that industry really has a problem with. So that would be just off the top of my head an approach to initial look at a program.
Okay, thanks, Michael. Next question. We have AWP champions. Do we also need to have standardization champions?
I'll take that. This is Mike.
Go ahead.
It's funny someone's asked that, because we were doing the same thing. We're in the process. Our modularization community business assessment is looking at whether we should have a special modularization sort of look at AWP and how it relates. And I think because modularization and standardization are somewhat tied at the hip, I think it's also very important that the same factors that require you to look early at modularization are also going to require that you look early at, or even earlier, at standardization. So yes, there is some more work that needs to be done to try to see just how AWP fits, or what pieces of AWP are considered a priority for making sure that you get the right people and material at the place and you do the proper interfacing.
Thanks, Michael. The next question we have, are you taking into consideration equipment and spares standardization in order to achieve common spares benefits, also obsolescence and new to market challenges?
Mike, this is Tim. I'll take a shot at that question. The short answer is yes. Where programs have standardized, they have been able to have common spares within their projects that shared same sized equipment. And so as far as new technologies, I think that's just something that the team has to evaluate and look at, the strategy, review the OEM recommendations, and consider the, the life cycle failure analysis for different components in a particular machine or piece of equipment, and determine your strategy. But yes, standardizing, spares within a program is definitely something that a lot of teams have capitalized on.
Thanks, Tim. Next question, how do you see systems engineering fitting into a standardization approach?
Kathy, would you like to? Okay, go ahead, Michael.
Systems, you mean process systems, I'm assuming, but if that's the correct question, my experience is there's always, while there's proprietary parts of a process, there are always a lot of utilities, and there's a lot of processes that are relatively similar from one program or project to another. And I think this is where you ought to key your interest in is trying to identify those areas early on. They may be subsystems, they may be parts of equipment or whatever that can be made robust enough to where they can go ahead and cover more of the general needs as opposed to some proprietary system designs. So I think within any project, there are always parts of it that are relatively similar. Obvious ones to me, of course, are like the utilities and that sort of thing. Someone else may be able to add on to that.
Okay, I think we have time for one more. How can EPC companies help owners to understand the benefits of standardization, given the fact that 85% of the CSFs are owners' responsibilities?
Mike, this is Tim. I'll take that question. I think what's important for EPCs is just to understand the standardization process and the timing of involvement of completing CSFs, and work with their customers to provide discipline in the process. And so just asking the right questions at the right time, figuring out what components or systems could be standardized to help their programs is a good place to start. So, you know, a big part of standardization is vendor involvement and subject matter experts. And so we see EPC companies as a strong SME supplier for different disciplines, mechanical, electrical, controls, equipment, rotating equipment, fixed equipment. So their role in helping standardization can be very significant and very beneficial to their clients.
Okay, great. Thanks, team, for the great presentation and good answers to the questions. That's all the time we have for today, unfortunately. But thank you very much for joining us. We appreciate your time, and we hope that you found the webinar useful. Don't forget to check out our events page to sign up for future webinars. Stay safe, and we'll see you next time.